Welcome back, everybody. So we have done with the spanning tree protocol, right? Can anyone tell me what is the problem with the spanning tree protocol? So we have spent almost 1+ week in the spanning tree protocol, and we have seen that different flavor of the spanning tree, like a CST, PBST, RSTP, or we can say the MSTP protocol, right? And we have seen the security of the spanning tree, how you can secure the spanning tree network by using the root guard, BPD guard, BPD filter, loop guard. You can enable the port fast feature to skip the listening and learning state, right? And we have seen the BPD version 0, then 2 and 3, right? And in the MSTP, we have seen that how you can map the instance to the VLAN, right? And those information will be exchanged in the hash format, not the complete information. But can anyone tell me what is the main issue with the spanning tree protocol? What is the main problem? Anyone? Anyone knows what's the issue with the spanning tree?
It's a loop that is created in a network.
That's not a problem, man. That's a solution because you have
Yeah.
loop, and that's a solution of the spanning tree. STP was introduced as a solution of the layer 2 loop. I'm asking the problem. I'm not asking the benefits of the spanning tree. I'm asking the problem, the drawback of the spanning tree protocol. Anyone? Delete timing to add and remove the VLANs? No. That's we have resolved in the RPVST.
Probably you were talking about the time it takes.
No, timing doesn't have an issue, right? Timing issue we have resolved in the RPVST protocol. RPVST is a very faster protocol, right? We have seen that in just giving the output in the millisecond, right? So timing doesn't have issue, man. I'm talking overall the spanning tree problem. The problem with the spanning tree, if you have a look, try to understand in this case, right? Packet able to create inefficient path in the network. Yeah, that's one of the good ones, sir. The create inefficient path in the network. So take example, we have our switch 1, right? We have a switch 2. Understand this concept, right? What happened? If I'm gonna connect this guy into the 4 different links. So take example, each link, the capacity of each link is what? 10 gig. The capacity of each link is what? 10 gig. So we have a switch 1, right? We have a switch 2. The capacity of this link is a 10 gig, the 10 gig, and the 10 gig, and the 10 gig. Normally, what happened if this guy will become the root bridge, this guy will become the non-root bridge, then what happened? All this port will be DP, this DP, this DP, and this DP. One port go in the RP, and remaining port go in the blocking state. Remaining port go in the blocking state. So whatever the user, take example, we have a user 1, user 2, user 3, and user 4 behind the switch 1, right? What they will do that if they understand the traffic to this user, which is behind the switch 2 right now, in this case, what happened? All my traffic will go via which path? So for example, if the PC1 wants to communicate with another PC, they will go via the first link. PC2 same way, they go via the first link. PC3 same way, they go via the first link. PC4 go via the same way. So we can call it, like, hypothetically, we can call it 2.5 Mbps bandwidth we are selling to each other. So can you imagine that what's happening in this domain? We are totally wastage of bandwidth of this particular link. We are not able to utilize that link. That's the first issue with the spanning tree protocol is what? Right? If you're gonna create, if you run the spanning tree protocol in your layer 2 network, it create an issue like you're not gonna utilize the complete resources of the network. Okay. Take example, you may have a question, hey, Law, we have seen this thing like, by creating the VLANs and those things, by making a switch 1 as a root bridge for VLAN number 10, switch 2 as a root bridge for VLAN number 20, we can do that. But understand the concept. If you just have a single VLAN, then VLAN number 10, if you have a single VLAN 10, then either this one will be root bridge, either this one will be the root bridge, anyone. I don't have a multiple VLANs. Understand the issue now? If you have a multiple VLANs, maybe if you have a 10 and 20, 30 and 40, then you can say that, okay, I'll make this guy the 10, 20 as a root bridge, and this guy I'm going to make a 30 and 40 as a root bridge. In that case, you can achieve it. In that case, what happened? I can utilize all this link now. But take example, if you have just a single VLAN, if you just have a single VLAN, then what happens? If you just have a VLAN number 10 and VLAN number 10, then what? All the remaining port go in the blocking except the one. First issue. Second issue, in this case, what happened? It's a wastage of link. In this case, what happens? It's a wastage of link over there. Second case is what happened. Let's take example. We have a PC1, we have a PC2, right? Switch 1 we have, switch 2 we have. We did this lab as well. If you guys remember that, switch 3 we have, and switch 4 we have, right? So what happened? Take example, if the switch 4 is a, or maybe the switch 2 is a root bridge right now. So all my this port will be DP, RP, and then this guy will be the RP, this guy will be the DP, this guy may be the blocking, and this guy will be RP, and this guy will be DP again, right? Now what? Take example, we have a PC over there and we have a PC over there. So if this PC1 wants to communicate with the, for example, the PC1 wants to communicate with the PC3 and PC4, then what happened? All my traffic, right? All my traffic will follow this path. It means that I'm not going to utilize this particular resources. So in this case, what happened? We are wastage of this particular link bandwidth, wastage of this particular link bandwidth, and the complete switch as well. Again, you have a question, law. We can change it. We can make this guy the root bridge, but it's still what? I just have a single VLAN. This is the second problem, right? It depends on the topology. Problems comes in the picture, right? Third issue. Third issue is what? Take example, we have a switch 1 now. We have a switch 2. We have a switch 3. Right? We have a PCs over there. We have another PCs. PC 1.1.1.1.1.1, PC 1.1.1.2, right? And the MAC addresses of this guy's a B, this guy's a MAC address A 0/2 we have, 0/2 we have, 0/0 we have, 0/0 we have, 0/1 we have, 0/1 and 0/0 and 0/1. So take example, router switch 1 is my root bridge, right? So this port will be DP, RP and RP, right? This port will be DP and this port with the blocking. Remember, the blocking port cannot send and receive the data traffic. Cannot send and receive data traffic. That's the meaning of blocking port. Now you tell me one thing. In the blocking port, what I can do that only? I can only receive the BPD. That's the behavior of the blocking port. So on the blocking port, we cannot send and receive any kind of data traffic. So take example, if this PC wants to communicate with the PC number 2, how the packet flow will be there? What is this called now? Suboptimal path. Suboptimal path means what? If you see my network right now, my best path is what? I can directly go from here to it. Try to understand in this way. Take example, this switch in the Delhi. Okay. This switch in the Mumbai. And this switch in the Gurgaon. Understand the concept right now. Okay. In this way, you will understand. You tell me if you want to go from the, right, this PC is also located in Delhi right now. And this PC is also located in the Gurgaon. So normally the distance between the Delhi, right, to the Gurgaon is what? So guys who is not from the India, just let you know, these are the cities of India, right? So Delhi is the cities, Gurgaon is the cities, and Mumbai is a city in India. So the distance between the Delhi to Gurgaon is what? It's just a 50 kilometers approximately, right? So you tell me one thing, if I want to go from the Delhi to Gurgaon, I have a better path. I can go via this way as well, right? But due to the spanning tree protocol, due to the blocking port, what happened? If I'm going to go to the Delhi to Gurgaon, then I have to first go to the Mumbai, then Gurgaon, and then packet will come to the PC number 2. I have a suboptimal path. So guys, spanning tree that you have learned, see, everyone is talking about the benefits, the pros, right? you need to understand the cons as well, right? You need to understand the drawback, because in the complete 7 days, we have only discussed the benefits of the spanning tree protocol. Even the books are given like a benefits of the spanning tree. You need to understand the cons. If you know the drawbacks, you can easily explain to someone. So because of this reason, right? Because of this reason, spanning tree, right? It not always recommendation to run in the entire in the data center network. In the data center network, you know what happened now? It is what I told you. If you guys remember that spanning tree protocol, I told you that, right? Spanning tree protocol initially when it was introduced in the 90s, 80s, and 1990s time. On that time, it was necessary protocol. But nowadays, if you see, spanning tree has lots of issues. And that's why in the enterprise network, still we have a spanning tree protocol, right? Still we have a spanning tree protocol. But in the data center network, we don't have a many places we don't have a spanning tree. See, if you have an older data center, you still have a spanning tree, right? If you have a pure layer 2 network. But nowadays, we are completely changing the behavior from layer 2 to layer 3 now. So in a data center network, normally we have a layer 3 scenario, not the layer 2 scenario, right? Layer 2 scenario is there to just provide the connectivity with the server to the switches, that's all. But normally, pure spanning tree is not a partial spanning tree will be there, not the pure spanning tree, right? So to avoid this problem, not this problem, to avoid this problem, you can manipulate the cost and change the behavior. But to avoid this problem, right? This one, what we can do that I can aggregate, right? I can convert all this 4 link into the single link. I will convert this all 4 link into the single link. Or we can say that I will aggregate all this 4 link into the single link. Aggregation is what? Converting into the one. Summarize it. So if you have a more information, I will summarize in the single. So if you have 4 link, link number 1, link number 2, link number 3, and link number 4, I will convert this guy into the single link. This mechanism is called as a port channel, or we can call as a ether channel. The reason we call as a ether channel, because this mechanism are only gonna run on the Ethernet media, not the serial link. So all this media, you can see that it's a fast Ethernet, maybe gig Ethernet, maybe fast Ethernet, maybe Ethernet. Or sometimes people call as a link aggregation, because we are aggregating the link over there. So by running the port channel, or we can call it ether channel, what we can do that now, I will create the logical topology for this one. So normally what happened, this 4 link will be converted into the single link. Now the topology will be something like this. So we have a switch 1. This is my logical topology. We have a switch 2, right? We have a switch 1, we have a switch 2 now. And my link will be between this guy to this guy over here. So now I have a single link. And this link will be, I can call as any name I can call it. I'll make this guy a port channel, maybe the 2. I'll call as a port channel 2, or maybe the whatever the number you are not defining, it's up to you. So when I'm going to convert this 4 link into the 1 link, right? When I'm going to convert this 4 link into the 1 link, I need to define the name of this logical link. I need to define the name of this logical link. And that logical name is called as a port channel. It could be the any number. So now you tell me one thing. If you have only 1 link, so what happened? This guy still has a root bridge. This guy will be non-root bridge. Then what happened? This guy will be called as a DP port, and this guy will be called as a RP port. And whatever the bandwidth, you can see that 10, 10, 10, 10, 10, all this will be added to this logical link, 40 Mbps. So this was the 10 Mbps. All this 10, 10, 10, 10 is added. Now it's become the 40 Mbps. So now there will be a no blocking port. I can utilize my all the links. So normally now I'm going to run the spanning tree protocol. Now I'm going to run the spanning tree protocol on the logical network. Now STP will run on logical network. Not the physical network. So in the logical network, you can see that, right? I just have a one link. So if you have just one link, I will either one port will be a DP, another port will be a RP. Yeah, if you're gonna convert, take example, if I'm gonna convert this two link in the single one and this two link into single one. So what happened? I can call this guy the port channel one. I can call this guy the port channel two. So now my logical topology will be what? The logical topology like this way. So we have a one port channel one and port channel two. So we have called the port channel one and port channel two. So if you're gonna aggregate in this way, then what happened? Switch one, switch two, which is the root bridge, and which is the another one in the root bridge. In this case, what happened? This guy will be the DP, this guy will be the DP. One port will be RP, another port in the go in the block mode. So your designing should be accurate. If your designing is a bad, if your network design is a bad, then you will face the issue in your network. So the issue is what? We have a multiple blocking ports over there, right? To avoid this problem, what happened? I aggregate this particularly. To do the aggregation, we can call as a port channel, or either we can call as an ether channel, because these are all are Ethernet media, and either we can call as a link aggregation because we are aggregating this physical link into the logical link. And now on this logical network, this is my physical network, and this is my logical network. On this logical network, what happened? I'm going to run the spanning tree protocol. So whatever the link bandwidth we have, all will be added to this guy. But there is a criteria to make a port channel, or we can say that to make a ether channel, there is a criteria. The criteria is what? Your duplex has to be matched. So if this guy's a full duplex link, if this guy's a full duplex link, this guy's a full duplex, this guy's a full duplex, it also has to be the full duplex link. If anyone is a half duplex, then your port channel will be never up. It will be down. So make sure that your duplex should be right same. So one side is a full duplex, another side also will be a full duplex. If one side is a half duplex, another should be also a half duplex. It should be not a mismatch one. Second thing is what? Speed has to be same. Speed, if this guy is a 10 Mbps, if the link one is a 10 Mbps, link two also should be a 10 Mbps. Link three also will be a 10 Mbps. If I'm gonna make this guy a 100 Mbps, then what happened? Your port channel will be also not up. So link speed should be same. Third thing is what? Native VLAN and allowed VLAN are same. So remember, we have seen the command switch port trunk allowed VLAN, right? And native VLAN concept. So take example, if the native VLAN is one, right? The native VLAN is one. If the native VLAN is one, if this guy has a two, then also again the ether channel will be not up. Make sure that it's also should be the one. Same native VLAN and same trunk allowed VLAN should be configured. So take example, if this guy is configured with the trunk allowed VLAN is a 1020, and this guy's configured the 1020, and this guy's configured only 10, and this guy's a 1020, then what happened? Again, your ether channel should be not out. So make sure that you have a same configuration. Then what? All the interface should be the trunk, right? It's not should be the combination of that ones. For example, this should be the access, and this is the trunk, and this will be access, this is the trunk. Again, the link will be not come up. Your ether channel will be not come. Make sure that all they have a same trunk, or either the access, either the trunk over there. And the most important is what? Trunking protocol. The trunking protocol is what? The 80.1q or the ISL. So make sure that all they have are either ISL or all they have either 80.1. So this criteria has to be matched. If this all the criteria will match, then your logical topology or ether channel comes in the picture. So now to make a ether channel, we have some way, or we can say that we are two. There is a two ways to deploy the ether channel, or we can say the port channel. There's a two ways to deploy port channel, right? Or we can call it ether channel, right? Or we can call it a link aggregation. So one way is called as a static. That's called as a manual way. Second is called as a dynamic. As the name suggests, as a static or manual means what? A network engineer has to go on the edge switch, right? So if you have a switch 1 and switch 2, so the network engineer has to log into the switch 1 and do the configuration. Then network engineer has to do the login to the switch 2 and then do the configuration. So it's like a box to box configuration. The network engineer has to do that, right? In a dynamic, again, the dynamic comes in the picture. What happened? We have a protocol. The protocol we have, either it could be the LSCP or either it could be the PAGP protocol. So LSCP, the simple language, it's a IEEE standard protocol, and PAGP is a Cisco proprietary protocol. In a static, what happened? We have a mode. The mode is called the on mode. So take example, we have a switch 1 and we have a switch 2, and I'm gonna make this 2 link as a port channel. So what happened? I need to define the on mode on this guy, and I need to define the on mode on this guy. Then your link will be converted into the port channel. It's not like that. I can configure the one side as a on mode, another side as a LSCP protocol. It's not gonna work. So make sure that both are the static and both are the dynamic. And even it's not going to work like that way. For example, if I'm going to run the switch 2 as a LSCP or switch 1 as a PAGP protocol, it's not going to work. So in the LSCP, right? Hold on. In a LSCP, we have a 2 mode. One is called the active mode, right? Another is called the passive. Let me show you this configuration first of all on mode, right? Then I'll come to the show you the dynamic behavior. So let me configure this guy first. So what I can do that, if you see, this is my topology switch 1, switch 2, right? So I don't have any configuration right now such. Let me check it. No, I don't have. Yes. And no, and yes. So by default, the spanning tree protocol will be there. So they are running with the RSTP right now. So spanning tree summary, if you see that. Let me change with the PVST mode. Let's make a simple. Host name will be switch to. So it doesn't mean that we cannot run this EtherChannel on the RPVST mode. You can run it. I'm just making the simple one, making the PVST because PVST doesn't have any issue, right? So now you can see that what by default the spanning tree protocol is enabled. If you put the command so spanning tree summary, you can see that the switch 1 is a root bridge. The reason is that because of the lower MAC address, the MAC address is 000. This guy's a 0200 is a MAC address. This guy will become the non-root bridge. So if you see on all the ports, right, 0/0, 1, 2, and 3, they all are in the what? Designated forwarding. So they are in the learning state, wait for some time. Now it's coming the forwarding. But the problem is what right now? The switch 2, if you see the do switch spanning tree, he's saying, hey, my one port, that's a 0/0 is the root forwarding. My remaining port, the 0/0 is the root forwarding port. This is the RP port right now. By remaining is the blocking. That's a problem. I cannot send the data traffic from this particular interface. I cannot receive the data traffic from this particular interface. So it's a wastage of particular link bandwidth, right? So what I can do that. So the first thing, I'm not gonna changing any behavior. My duplex is same, right? My duplex is same. I don't configure any VLANs right now. The VLAN 1 is already there, right? I just configure the trunk. So interface range is 0/0 to 3 switch port trunk encapsulation .1 view. Switch port mode trunk, right? That's fine. So that they can send and receive the data traffic. So of course the switch 2 will form the trunking as well because they have a negotiate, right? All good. What I can do that now? I'll go the interface range 0/0 to 3. I see that the first command I will say the channel, right? Channel is what? I'm gonna create the logical path. The meaning of this keyword is what? I'm gonna create the logical path. I'm gonna create the logical path. And to create the logical path, what I have to do, I need to group it. I need to group it. What I'm gonna group it? I'm gonna group the physical link. And when I'm going to group the physical link, then what happened? I need to define the ID of that logical link. So the first command is as channel, the second is the group. Now, what is the group name? I'm going to define it over there. I say the one. Any number, you can take it from the 255. And then I can say the mode is what? I can say the on mode. That's meaning static behavior. That's the meaning of static behavior. So before gonna do the EtherChannel configuration, it is a recommendation to shut down all the interface first of all. Right? It is recommended. Otherwise, what happens due to the mismatch of the packets, right? Maybe for the some time, right? Maybe the 10-second and 20-second, your interface will go in the error disable state. So that's a recommendation in the, even in the production network too, right? So what I can do that, I'm just gonna shut down this particular link. Same thing on the router switch 2 as well. Interface read 0/023, shut down it. And now I'm gonna run the command again. Channel group 1, mode will be on. That's my static behavior. And the channel group 1, mode will be on. And now I'm gonna no shutdown this guy. No shutdown and no shutdown. So understand a difference right now. Let me show you the first this difference. Right? And here we go. So previously I was running the spanning tree protocol on the physical media, right? Now, if you see that, now I have a logical link, do show IP interface, brief. My port channel is up right now. Okay. And if you the so spanning, so port channel summary. So EtherChannel summary, you can see that my port channel PO1, right? These are the links that we have binded, right? And the SU means what? S means it's a greater than S. The small s means suspended. The S means you have seen, there will be a marker over there, man. Come on. It's a meaning of layer 2 in use, something like that. Yeah, layer 2 in use. So my EtherChannel is working fine. Even if you check on the switch 1 right now, do so port channel summary. Right? Come on. So port channel. So EtherChannel summary. EtherChannel summary. And now you can see that on the switch 1 as well. My all the links is working fine. So simple command, nothing you need to do extra things. My group 1, right? Port channel is up, all my interface is binded. The beauty part, if you see right now, what? So spanning tree. What you can see that? My all this link, right? E0/0, 1 and 2, 3 is not there now. They are converted into the port channel 1. So we are running the, right? We are running the spanning tree on the port channel. See? Now, if you have a look, so interface port channel 1, what you can find that total bandwidth is what now? 40 meg. Previously, each link was a 10 meg, right? Now we have converted into the 40 meg. So there is no blocking over there. I can utilize all my traffic. I can utilize all my bandwidth. So instead of running the span tree on the physical link, now I'm running the span tree on the logical link. So of course, I just have a logical topology is what? My logical topology is switch 1 we have now. We have a switch 2, right? And now we have 0/0 and 0/0 over there. Not 0/0, it's a port channel 1 and port channel 2. PO1 and PO1. So on this particular link, I'm running the spine tree protocol. And the capacity of this thing is what? 40 meg. Understood? Same way, what you can do that. The another way that you have to configure the ether channel, or we can call it a port channel, apart from the manual or static configuration, we have a two ways. One is called the LSCP, another is called the PGP. So in the LSCP, what happened? We have a two modes. One is called the active and passive. To active and passive. Active means what? I can initiate the right same behavior like a DTP protocol. If you guys remember that. In active, what happened? I can initiate the ether channel request. What passive can do that? Passive can accept it. So he can initiate the request. At the same time, he can accept the request. If someone is responding that, hey, let's form the ether channel. So active has the ability to initiate it and accept the request. But the passive can only accept the request. They don't have an ability to initiate the port channel request. Passive does not have an ability to initiate the port channel request. They only can accept the port channel request. So what happens if you take example, if you have a switch 1 and if you have a switch 2 over there, understand this concept. We have a 0/0 and we have a 0/0, right? Let's take a two link right now. I have a switch 1, this link and this link. So I'm going to make a port channel on this guy, 0/0 and 0/0 and 0/1 and 0/1, right? So now what I can do that over there, I'm going to configure the LSCP. So in the LSCP picture, what happened? On one side, I'm going to configure the active. On the other side, I'm going to configure as a passive. So what happened? They will make a request. Hey, let's form the ether channel. The passive has the ability to accept the request and form the ether channel over there. But what happened? If I'm going to make a active on this guy and active on this guy, also will work. So the port channel will be up over there. But if the both side will be the passive and passive, right? The both side will be the passive and passive, the ether channel will be never work. So make sure that you have a combination of active and passive, or either active and active. Now let me tell you the production wise. Mainly I have seen in the production, right? People are using the active, right? So on the both the side, people are using the active scenario. So that's I have seen the like in a service provider network, because you can do the ether channel, right? Or we can call as a port bundling as well. The name is called the port bundling. Bundle means what? We have multiple links. So you can do as a layer 2 and layer 3 as well, right? Layer 2 means what that we are doing right now. You can do on the layer 3 as well, right? So I have seen that people are using the active in the both scenario. So on the switch 1 and or we can say router 1 and router 2, they are using the active scenario. But it doesn't mean that you cannot use the active and passive. You can use the active passive. So in this case right now, what I can do that, I'm just going to use the active and passive scenario. That's the LSCP. So let me remove the first port channel I have. So interface range is 0/003 as the shutdown. Same way I want to shut down this link. Shutdown. And as the node channel group, one mode will be on. And I'm going to remove the static behavior, node channel group. One mode will be on, right? And now what I can do that, as the channel group, right? As the one, that's a port channel number, or we can call it the interface we have, right? So whatever the number you're going to define over there, that will become a interface number. That will become an interface number. So as a channel of 1, and what mode will be, I can call as a active for LSCP, other switch 1. And this guy is called as a channel group. One mode will be passive. Passive means what? Enable the LSCP only if the device is detected, means I can only accept the request. Right? If you have active means what? Enable the LSCP unconditionally. So I can send the request, I can accept the request, no issue. So now if I'm going to turn on this interface now, no shutdown and no shutdown, right? It's going to work. So now you can see that so spanning tree summary. First you have so the so EtherChannel summary. Right now you can see that the protocol is now LSCP. Previously, if you remember that, it was a on, right? No protocol, on mode. But now we have a protocol over there. That's my LSCP protocol. My port channel 1 is up. And if you see the source spanning tree summary, source spanning tree now, you can see that. Wait for some time, it's going the learning and listing state right now. Now it's coming the forwarding. Simple command, you just need to identify, right? One side is the active. So I just did the active on this switch 1, right? And the switch 2, I did the passive over there. So even you can use the active scenario as well. That's not a big deal. But don't use the passive and passive. This will not work because the passive is just saying that, hey, I can make a port channel. If I'm going to detect it, the neighbor is running with the LCP, right? The active LCP. The another mode we have, right? We have another protocol we have, it's called the PAGP, right? The PAGP, we have a it's called the 2 mode again. We have a auto and desirable. Remember the same thing is there in the DTP protocol, auto and desirable. So the same behavior, switch 1 and switch 2. So one side you can make a desirable means what? I can initiate the request of the port channel. At the same time, I can accept the request for the port channel. Auto means what? I can only accept the request for the port channel. I cannot initiate it. So switch 1 should be the desirable, right? And switch 2 should be the auto. We will have a EtherChannel. But if the switch 1, right, take example, if the switch 1 is a auto and switch 2 also are the auto, then in that case, the port channel V never comes up. Same behavior. The switch 1 we have, switch 2 we have, and even if you have a desirable and desirable, both will be up. But don't ever do like this way. Never switch 1 as a LSCP protocol and switch 2 have a PAGP protocol. It's not going to work. The reason it's not going to work because both have a different packet mechanism. They are sending the different packet types, right? So they will not work over there. So LSCP is IEEE standard protocol. So if you have a different vendor, then you can go with the LSCP protocol. But if the switch 1 and switch 2 both are Cisco and Cisco, right? If the switch 1 is a Cisco and switch 2 is also Cisco, right? Then you can go with the PAGP protocol. But take example, if the switch 1, right? If the switch 1 is a Cisco and the another device, maybe the Juniper, right? Then you have to go with the LSCP protocol. Right? In the both protocol, what happened? You can maximum bundle the 8 links. So either you're going to use the LSCP protocol or PAGP protocol. Maximum you can have 8 links as an active one. So PAGP allow you to bundle the 8 links, right? Which will be the active, all the active links will be there. Active is what I can send and receive the data traffic from that particular link. But LSCP allow you to bundle the 16 links, right? But again, these things, right? I'm talking about the iOS perspective, depend on the platform, right? If you go in the data center network or if you go on the XR side, right? Service provider network, these things are totally different. These things are changeable. So we are talking about the enterprise perspective, iOS perspective. So if you have a bundle, you can bundle the 16 links, but it will be active and remaining 8 will be standby. Standby means what? I can send the data traffic. It means that something like this way. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So all this 8 link will be the active link, right? And the remaining, this will be the active one. So you can send and receive the data traffic if you're going to implement the LSCP protocol, right? If you have this number of the links, then I'm talking about the rare scenario, right? The remaining 8 links, right? Remaining 8 links will go in the standby. It means that you cannot send and receive the data traffic from this particular link. This will be in the standby. So if the one of the link, for example, if the port number 8 goes down, understood this concept. If the port number 8 goes down, then 9 will become the active one. So only 8 will be the active in the LSCP scenario. So either you are going to use the PHP protocol or LSCP protocol. Maximum you have 8 links will be the active. Now, do you remember how question, hey, log, how would the packet forwarding now? So take example, let's go into this switch one and switch two perspective right now. So I just, for example, I just use the PHP protocol. Have I done the PHP lab? Not right. Yeah, we have done. No, we haven't done. So let me remove this guy. Let me show you the PHP behavior. So I'm going to shut down this guy first of all. And I'm going to remove this person. Same thing on the switch two right now. Shut down. And I said no. Channel group S. Now I said the channel group 1. And then I guess the mode will be what? This auto. And the switch one I said that channel group desirable. No shutdown. No shutdown. My port channel is not came up. So now you can see that do show. Now you can see that do show EtherChannel summary. I have a PHP protocol. S means what? Late to in use. Late to in use, right? So you can have a layer 3 as well as, but right now we are doing the layer 2 behavior, right? So you can see the spanning tree. I have a root port now. The port. It's a PHP protocol. It's a PHP, and this is the root port. But understand this concept right now. We have a switch one. What we have done? We have a logical. This topology is a logical topology, right? Switch two we have. So this is the port channel 1. Right? This is the DP port. This is the RP port. This is the root bridge, and this is the non-root bridge. The capacity of this link is now what? It's a 14 meg. Right? You can see that. So interface port channel 1. So individually it was a 10, 10, 10, 10, 10. Now I convert it into the single link. So I will add the bandwidth over there. So it was a 10, 10, 10, 10. So I have added this bandwidth to the logical link now. So this is my logical topology, right? This is my physical topology. This is my physical topology. This is my logical topology. What do you think that? Will I going to send the data traffic from the logical network? Logical means what? It's a virtual. Virtual VLAN, remember the VLAN concept? The virtual. Virtual means what? Something that is present, right? Something that is present, but you cannot see that. Something that is present, but you cannot see that. That's the meaning of virtual. Physical means what? Something that is present, right? And we can see that as well. That's my law, physical one. So on a virtual, right, you cannot send and receive the data traffic. In networking, right, remember one thing, always, you will now, you will encounter the many words regarding the virtual. Either you talk about the VPN, the virtual private network, the VLAN, the virtual local area network, the VRF, virtual routing forwarding, right? Even if you go in the SD-WAN technology, SDXS technology, ACI technology, right? Many things are there in the market right now. Many things are virtual. That's an overlay, we can call it. So another term right now the people are using is called overlay. You will have this word when I'm going to talk about the SD-WAN technology, right? When I'm going to give you the theory part of the SD-WAN, I'll say the overlay. What is the meaning of overlay? So anyway, the virtual topology cannot forward your data traffic. My data traffic is still go by the physical topology. My data traffic is still carried by the physical topology. So how the data traffic will be carried over there? So this data traffic is carried based on the load balancing algorithm. So in the ether channel, right? So the data will be travel, either data can travel based on the E0/0, maybe the E0/1, or maybe the E0/2, or maybe the E0/3. It's totally depend on the layer 2 load balancing algorithm. So when the user, take example, when the user is sitting behind the switch 1, right? And the user is sitting behind the switch 2, sorry, switch 1 as well. And here we have another user, here we have another user. So take example, right? So when the PC1 wants to communicate with when the PC1 wants to communicate with the PC3, and the PC2 wants to communicate with the PC number 4, right? Understand this concept, what happened? Maybe when this guy is going to send the traffic, right? Maybe when the PC1 want to send the traffic to the PC3, my packet will go by the, according to the load balancing, my packet will go by the 0/3. But when the PC2 wants to communicate with the PC4, the packet will go by the 0/0 as well. So this is how we are achieving the load balancing in the ether channel. It's depend on the which algorithm you are using. So basically in the ether channel, right? Basically in the ether channel, we have a load balancing algorithm. So it's depend, right, on the layer 2. So we have a layer 2 load balancing, we have a layer 3 load balancing, and we have a layer 4 load balancing. So in a layer 2 load balancing, what happens? Either you can do the load balancing based on the source MAC address. Either you can do the load balancing based on the destination MAC address, right? Either you can do the load balancing on the based on the source and destination MAC address. Right? On a layer 3, if I talk about, on a layer 3, what happened? You can do the load balancing based on the source IP, destination IP, or source plus destination IP. If I talk about the layer 4 perspective, right? In the layer 4, what happened? We have a port number, remember? So we can do the source port number, we can do the destination port number, and we can do the source plus destination port number. Now you may have a question, which algorithm is enabled by default? Again, it's depend on the platform. First of all, in the higher end router, this will be support. In the higher end switches or router, this will be support. Right? Basic model of the switches and router can support these two things. So you can use the any combination. So switch 1 can use the, for example, switch 1 can do the load balancing based on the source MAC, right? The switch 2 can do the load balancing based on the, right, destination MAC as well. There is no issue. We can do that. Where the switch 1 can do the load balancing based on the source plus destination MAC. Switch 2 can do the load balancing based on the source IP. So you can also use the combination of these things, right? There's no issue. But the layer for the port number concept, right? It is only gonna support in the higher end. So if you see the right now, the default behavior, what default behavior I have? So port channel. So ether channel, port channel. Load balance. So the destination is so right now they are using the source and destination IP. Even it's a layer 2 port channel, we are using the source channel. So if you want to change it, you can change it. So for example, I say the port channel load balance, I have options over there. So you can see that I don't have a port concept. I have a destination IP, destination MAC, source destination IP, source destination MAC, source IP or source MAC. So I can use the, for example, the switch 2 is running with the default is a source and destination IP. I can use the source and destination MAC. There will be a no issue. Not put the same command. So ether channel load balance. I still have a ether channel summaries up right now. So there's no issue in the ether channel. So one side you can use the, source and destination MAC. On the another side, right, on the switch 2 side, if you see, I'm using the source and destination IP. So ether channel load balancing. So the combination of you can use it, there's no issue. So based on this algorithm, they are deciding which port should I use to forward the packet. Remember always, your logical network, your logical topology is not going to help you to forward the packet. Your logical topology is just helping you, right, to avoid the blocking ports. That's all. But all my data traffic will go by the physical port. Which port the switch will pick, they are totally dependent on the algorithm. Guys, questions?
Basically, usually in simple terms, the main function of the ether channel is when there are multiple links in between two switches, right?
Right. So all
So
the links will, only one link will be active. All the links will go in the blocking, right? So to avoid the blocking ports, we can do the ether channel. That's a main.
sorry, your line is not very voice is so low. Um, uh, so
So
one link is
normally what happened? Understand this concept. Switch one, we have multiple links over there. Take example. What happened in that case? So this guy will be the root bridge. This guy will be non-root bridge. So this will be the DP, 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 10 meg, 10 meg, 10 meg, 10 meg. So only this link will be root port, right? Baki all will go in the blocking, right? So it's a
that's
waste of
right, yeah.
bandwidth. So we can do the aggregation.
Okay, I see.
Make sure that the link has a connectivity with the same switches. It should not be like this way. I have a 2 ports over there on the switch 2, right? I have a 2 ports over there in the switch 3. Don't do that. It's not gonna work over there.
It has to be between two switches.
Between the two switches, right? It's not gonna work.
And one link should be designated port, other link should be root port, and the rest of will be blocking and
In the
transmitter.
normal
That's it.
scenario, in the normal scenario, if you don't use the port channel.
Okay.
That's why we are using the port channel, right? You came late. I see that.
Yeah, because I was stuck at work, so that was the reason.
Yeah. So my
Yeah, but
request first of all, I have a request to everybody. Please be on the time, right? That's a very important because you know what happened to me. So whenever you're coming the 10 minutes and 15 minutes and 20 minutes, so normally I have to keep adding the people over there, right? So I have to admit multiple times. So yeah, it's way of like my
yeah,
communication.
disturbance. That's right. Yeah.
So yeah, so to avoid this problem, so we have, so it's a complete wastage of this 30 meg link, right? So to avoid this link, we are gonna convert this physical link into the logical link. So now what happened? My logical topology will be like this way. Switch one, switch two. So now we are not gonna run the spanning tree on the physical link. We are gonna run the spanning tree on the logical link. That's my port channel. So this is the 40 meg now. So now we don't have
No.
blocking, right? Can you see that? We have just our DP and RP. We don't have any blocking over there.
Okay. No problem. That's fine. So I will listen the recording. So I mean, I'm sure that will clear the concept.
Yeah, right.
But
So does one boozer has a question, does EtherChannel work one or more than two switches? That's why I mentioned that it's not gonna work over there, man. It's not gonna work over there. You make sure that all the ports has a connectivity with the same switches. Switch one has to whatever the ports you have on the switch one, they have a connectivity with the neighboring switches, the same switches, not the two different switches. If you're gonna make this guy,
right.
in this case, the EtherChannel will not work. So if you want to make this guy over here, EtherChannel, then the concept is called the VPC. That comes in the data center. Most important topic of the data center, virtual port channel.
Sure. That's absolutely. So that was the topic today for the EtherChannel, right?
Right, that's a topic.
Thank you, sir.
Thanks much. So if this is finished, I have a question for the VLANs.
Yeah, go ahead.
Okay. Basically, excuse me.
Sorry,
Uh,
I lost you. Yeah, tell me.
okay. When we configure the VLAN, so we configure the, let's say, the port number 1 as a management VLAN, right? So, and rest, say about there are 10 devices, which includes the PC, printer, telephone lines,
In the
etc.
same management VLAN?
No, not in the same management. No. So rest of the devices, we will configure the data VLANs for the end devices,
So I
right?
can configure the VLAN number 20, right?
Yeah. Okay. So VLAN number 20 is for the data VLANs where we connect all the end devices.
Right, correct. Go ahead.
So if I say that for the management VLAN, so what is actually the function management VLAN? So from that specific board, we manage the whole switch, or what is actually the function of the management VLANs if you just configure it in, let's say, in port number 1?
Anyone can explain me this thing? What is the meaning of management VLAN? I think so.
Yeah, because
This thing we have discussed in the VLAN topic. Someone has asked this question to me, right? If I'm not wrong. Anyone can explain me? What is the purpose of management VLAN?
So I'll try. It's been a while, so I don't have. But
I
so
think
I
so you
believe
are
the
the guy
management.
that I think you are the guy though who asked me.
No, no, it wasn't me. But I'll try.
Okay.
So if, as I remember correctly, management VLAN is the VLAN with the where we configure an IP address to the VLAN. So that it allows access to the device itself, where we can, to configure and manage the device.
So basically,
Does that make sense?
the meaning of management means, so just to understand the concept. So Nasir has given the answer. Nisar, to manage the remote connection to the traffic. That's correct one. Okay. Switch port. What is the switch port? Kharaz, I am not in the understand your switch port concept. So management means what? You have to manage the network, right? That's a simple meaning. You have to manage the
that's right. Yeah.
network. Okay. Now the thing is that there is no specific management VLAN. First of all, I'll tell you. There is no specific. Either
Okay.
your VLAN could be the data VLAN, either your VLAN could be the voice VLAN. That's all. Okay. What we are considering, we are just defining the name. Okay, we are saying, okay, VLAN number 100. I'm just saying that this is the management VLAN. There is no specific any VLAN over there. You can define any VLAN as a management VLAN. You can consider it. Okay, this is the management VLAN. Now, why we are keeping two separate VLAN? Why we are not keeping the management user in the same VLAN number 20 over there? Why we are keeping a separate domain? The reason is that fault tolerance. Fault tolerance means what? Remember I told you that the what VLAN is creating over there. VLAN create the separate MAC address table. VLAN create the separate MAC address table. So if something attack is happening in the VLAN number 20, understand this concept. If some attack is happening in the VLAN number 20, because my users are present in the VLAN number 20, so any remote user or normal user or your company users can come in the VLAN number 20. It means that there is no so much security in the VLAN number 20. But normally there's a high security in the management VLAN, because through this management VLAN, I can access the entire switches, right? The entire network. Now, if there is an attack is happening in the VLAN number 20, right? What happened? Will it impact to the VLAN number 10? No, that's called as a fault tolerance. If something is happening in the one domain, it's not going to impact to the this domain user. But take example, if I'm going to put the management PC over there, if I'm going to put the management PC in the VLAN number 20, then what happened? Gone. If the attack is going to happen in the VLAN number 20, it will also gone. So that's why it's a recommendation to have. So whatever the management users are there, you have to keep in the different domain to just making the fault tolerance. Understood?
So basically, in management VLAN support, we do not.
It is not recommendation to put the normal use. You can put it. It's not a big deal, but that's not a good scenario.
So also, if I remember correctly, Mr. Sa, if as you mentioned earlier, also the fact that unlike routers or the end devices which have IP addresses assigned for them to be able to be accessible over network, switch ports by default, you don't have those IP addresses because they're layer
Right.
2 devices. So we
SBI.
create this VLAN and assign it an IP address. It could be,
Right.
the
That's when
same.
it is the SBI over there.
It could be any VLAN for, as you just explained, but by default, it's usually VLAN 1, I believe, where we assign an IP address to that VLAN so that we can access it remotely over the IP network, right? Otherwise, we could have 10 different VLANs in there, but there's nothing that would allow us to access the device itself for management or configuration purpose
Eventually,
unless
see,
there is an
it's normal
IP
behavior.
interface configured.
It's a normal behavior, Bidu. What, like if you have two different VLAN, right? VLAN number 20 and VLAN number 10. And if you want to access from this, if you want to communicate with this guy to this guy, you need to do the routing over there. You need to do the IPR, inter-VLAN routing. That's a, again, separate concept. But yeah, so management VLANs, that's a concept of management VLAN. We are going to keep the in a different domain. If you're going to put it in the same domain, issue comes in the picture instead.
But we do not connect any device to that VLAN, isn't it? No.
You can connect it. That's not a big deal. Who told you that? You can put it your devices in the management VLAN as well.
Okay, you can do that.
That's why you can put it.
No, but
Not
I think
recommendation to have it.
right. I think that's what Nasir Bhai was pointing out. That correct me if I'm mistaken, Nasir, but I think that's what you were pointing out, right? Like we in production business environment, we tend to keep the management VLAN separate if possible.
Always
right?
separate to just make a fault tolerance. So something is happening with the user side, it's not going to impact to the management. Take example, if something is going to impact to the management side, then what happens? You will lose the connectivity with the devices. Then you need to go to the data center, physically access the devices. Understood?
Right.
So we
Right,
are
right.
safe side,
I
right?
see.
It's isolation part. It's like a BTP transmute mode, transparent mode.
Right. So, for example, from my personal experience, let's say I was working in a project where we used to have these switches on these remote sites. So, unless and until we would do the basic configuration on these switches, and then the field operations engineers would actually take it on to the site, remote site, and do the what do you call it, install it in the rack, and then assign the management IP address on that VLAN so that we can then start accessing what you may call it, that remote switch from our network operations center. So unless they assigned that VLAN management VLAN IP, there was no way for us sitting in the network operations center to access that switch. Only the field ops who were physically locally connected to the switch could only access and configure the switch.
Right.
Does that make sense?
Right. Makes sense. You understood, Nasir,
So,
now?
any remote engineer, sorry to interrupt you.
Yeah, go ahead.
Any remote engineer if he wants to access a switch or do any change, delete, add, whatever he wants to do in regards to VLANs, he just simply go to the management VLANs, put that specific port. So, and that's it, then he can do the rest.
Right.
That is for the remote access.
Yeah, from the management side, they can do that. Yes, right.
Okay. I see.
Because
Because I was in that project today.
management has eventually all the access of the devices, right? They have all the username and password of all the devices, so they can do that. Yes. That's
Okay,
why
no problem.
that's
Because
why
I was
in the company's network, what happened? We have a separate IT person guy. IT guy is a separate guy. IT room is a separate one, and the normal users are sitting in the normal places, right? So we are removing the, so something is happening in the normal guys. So IT guys are always help to the normal person, right? But ITs are always isolated. So a management VLAN is like IT, right? So we need to keep in the different section. Understood?
That's okay, no problem. That's absolutely fine. Yeah.
Anyone else any question, guys, from
Yes, sir.
VLAN span free EtherChannel?
No, sir. Understood. Understood, sir.
Great, guys. So as I mentioned that tomorrow we will not have a class, right? So Wednesday I have some